Hello guys, in this video I'm going to be showing y'all how to use ice tables to find specific concentrations of chemical compounds and how to find the chemical constant. Okay, so first we have a problem here. Let's go ahead and read it. A chemist places 0.5 m of SO3 into a rigid container. No SO2 or O2 are present at the start. After the system reaches equilibrium, the chemist measures the concentration of oxygen O2 and finds it to be 0.15 m. Calculate the equilibrium concentrations of SO3 and SO2. The balance equation is 2SO3 gas produces 2SO2 gas plus O2 gas. Okay, so it's asking us to find the concentrations of SO3 and SO2 when they're at equilibrium. So first things first, let's set up our ice table. And to do so, you just simply do this. It's going to be an I, C, and E. And what this acronym stands for is I stands for initial. And this is the initial concentration for the chemical compound, before the reaction takes place. C is the change, which is basically saying what happened to the initial for it to get into its final equilibrium concentration. And E stands for equilibrium, which is the value of the concentration once it's at equilibrium. So now that we know that, let's go ahead and fill it in. So I like to write, the chemical compounds above. So it's going to be 2SO3. Actually, maybe I should use another color real quick. Let me use another color real quick, guys. So 2S. Wait, that's not even a 2. I'm sorry. Hold on. Okay. It's going to be 2SO3. And then we're going to have 2SO2. And then finally O2. So the initial, it says a chemist places 0.5 m of SO3 into a rigid container. So that tells us what the initial is for SO3. So we're going to put 0.5 m. And then the question says no SO2 or O2 are present. So that means these are going to be 0. Which makes sense because they're both products. And you can't have any product before the reaction hasn't even started yet. So it makes sense for it to be 0. Now for change, the way we represent change when doing this is by simply putting x. X is a variable that represents change. And what we also do is, if the compound has a coefficient, then we also add that coefficient to the x. So this is going to turn into 2x, 2x, and this doesn't have a coefficient, so it can just stay as x. And also, one last thing when dealing with change, the products, which are these two right here, we're going to put plus x. And for the reactants, we're going to put minus 2x because when a reaction occurs, the reactants are getting consumed to produce the product. Okay, and then the question was so nice and even gave us an equilibrium value for oxygen. It says after the system reaches equilibrium, oxygen concentration is 0.15. So once you have a column with all three values, you can solve for the rest of the equilibrium values, and you can even solve for the equilibrium constant. So now what we're going to do is we're going to use those values that I just circled, and we're going to plug it in like this. So the initial, 0, plus the change, plus x, should give you 0.5, right? Because the change happened to the initial, which then reached you to the equilibrium, which is 0.5. And now you can just solve this algebraically. You subtract 0 by both sides. Is this going to equal x equals 0.5? So now that we know what x is, we are now going to add x to all of these expressions, or I don't know the right terminology, but so we're gonna add x, which is 0.5, to all of these to find the equilibrium values for all of these chemical compounds. So I'm gonna change colors again. So it's gonna be let's solve for this one first. It's gonna be minus 2 times 0.5 times 0.5, and that's gonna equal your equilibrium, which is basically just, oh, I'm sorry, that's not gonna equal your equilibrium. That's going to equal 0.3, and to find its equilibrium, you take the initial and then you implement the change, which is minus 3. So it's going to be 0.5 minus 0.3, which equals 0.2. So that's one of them. And then we're going to do the same thing for this one right here. So I'm going to go ahead and erase this, so I have some room. It's going to be 2 times 0.5, which is going to equal positive 3. And then you just add that by 0. 0 plus 0.3 is equal to 0.3. And that's that. So these right here are all 3 concentrations at equilibrium. So what we first did is we set up our ice table and we filled it in. And then we saw that we had one full column filled out. And then we solved for x algebraically with 0 plus x equals 0.15. And then once we found out what x was, we could find out what the change was by substituting x for 0.15. And then once we figured out what the change was, we could then, add or subtract respectively to its initial value. So I'm going to erase some of this stuff right here, because now that we have all of the equilibrium concentrations, we can now find the equilibrium constant. Now, the way we represent the equilibrium constant is with the variable Kc. Now, keep in mind that Kc also equals to Qc at equilibrium. So the formula for Kc and Qc are the same. Now, you might be asking, what is the formula? The formula for Kc is the concentration of C times the concentration of D divided by the concentration of A times the concentration of B. I'm going to explain what all these variables are. So A and B, let me get a new color. A and B are the concentrations only at equilibrium for the reactants. Okay, so you could not use this value right here because this is your initial. If you plugged in this value into this formula, you will be incorrect. You can only do it at equilibrium. And C and D is the concentration for the products. And this little n right here is its coefficient. I'm just going to put, I don't have room. I'm going to just do a really long arrow. Is its coefficient. And the coefficient is the number that's in front of the chemical compound. So now that we know what the formula is, we know what the formula is, and we now know what all of the equilibrium concentrations are. We could just plug in the numbers. So I'm going to erase all of this. Okay. So Kc is going to equal the concentration of products, which is going to be 0.3. That is a very ugly 3. It's going to be 0.3 squared, because its coefficient is 2, times the other product, which is O2, and it's going to be 0.15. And you don't have to square it or anything because it has no coefficient. Divided by the reactant, which is 0.2. Squared, because its coefficient is 2. And then once you plug this into your calculator, I'm going to do 0.3 squared. That's going to equal 0.09 times 0.15. That's going to equal 0.0135 divided by 0.2 squared. And you're going to get 0.3375. So this is our constant. And 2SO3 at equilibrium is going to equal 0.2 m. 2SO2 at equilibrium is going to equal 0.3 m. And O2 at equilibrium is going to equal 0.15 m. And this is it. These are all of your answers right here. All right, so that last problem was on the easier side. As you progress in chemistry, most of those type of problems are going to require you to use the quadratic formula. And please do not be intimidated by this formula. All these letters that you see will be replaced by numbers. They are simply just variables. And you can honestly just put this on your calculator and get the answer. But I also want to mention this. If you remember from college algebra, this is the quadratic formula, but this is the quadratic equation. It's ax squared plus bx equals, plus c equals 0. And I want y'all to keep that in mind when we do this problem. Now let's go ahead and read the problem. N2O4 is a colorless gas that decomposes into brown nitrogen dioxide, NO2. At a certain temperature, the equilibrium constant is Kc equals 0.5. If you place 1 m of N2O4 into a container, what are the equilibrium concentrations of both gases? The balance equation is N2O4 produces 2NO2. So they're asking for all of the equilibrium concentrations, and the problem has given us the constant. So first things first, it's pretty easy to guess what it is. We are going to set up our ice table. Okay. Sorry, excuse me. We're going to set up our ice table. Remember, this represents the equilibrium, change, and initial. And then we're going to write our compounds here. Okay, so they do give us an initial. It says if you place 1 m of N2O4 into a container, so the initial is going to be 1 m. And then if the problem says otherwise, only if the problem says otherwise, but usually we assume that the product at initial is going to be 0, because you can't have any product if the reaction hasn't even started. So we're just going to put 0 right here. And then the change, remember, we represent the change with x. And I'm going to put 2x right here because the coefficient is 2. And I'm also going to put a plus sign because this is a product. And I'm going to put a minus sign because this is a reactant. And reactants get consumed and products get formed. Now, if this is a reverse reaction, the signs would be opposite. The reactants would be plus and the products would be subtracted. But this is a forward reaction, not a reverse reaction. And they don't give us any equilibrium values here. But we do ultimately know that this expression will equal the equilibrium. It will be 1 minus x and 0 plus 2x. These will ultimately equal the equilibrium. If you take the initial, implement the change, that equals the equilibrium. So we can simply just put that. Okay. They did give us the equilibrium constant. So I'm going to change colors again. And I'm going to put 0.5, because that's what Kc is. That's what the constant is, 0.5, equals, remember, it's products over reactants. So the product is for equilibrium, and you only use equilibrium values. So this is going to be the equilibrium value right here. And you can just put 2x, because 0 plus 2x is 2x. So it's going to be 2x squared, because the coefficient is 2, over the reactants, which is 1 minus x. And you don't have to square it or anything because there's no coefficient. So first things first is you want to get rid of this fraction here. And the way to do so is multiplying both sides by 1 minus x. So it's going to be 0.5 times 1 minus x equals, and you can simplify this 2x squared because 2 squared is 4, x squared is x squared. So it's just going to be 4x squared. Now remember, we want to take this right here and convert it into this. So what we're first going to do is, I'm actually going to make some room here. I'm going to delete this. So I'm going to change colors again. What we're first going to do is now we are going to distribute the 0.5. So 0.5 times 1 is 0.5. 0.5 times minus x equals minus 0.5x. And then we're going, well, actually, let's do this first. Equals 4x squared, right? Now we're going to try to move this 4x to the other side. So it's going to, but when doing so, you must reverse these signs. You must flip them. So it's going to be 4x squared. This was a positive 0.5, but now it's going to be minus 0.5. And this was a negative 0.5, but now it's going to be a positive 0.5x. Because when you move something to a whole nother side, you must flip the signs. And that's going to equal 0. And we're almost to this expression. All we have to do is just flip these two numbers. And that's ultimately going to equal to 4x squared plus 0.5x minus 0.5 equals 0. So now we have our quadratic equation. We have the values. Now all we have to do is substitute these variables with these values. So A is going to be the number that's in front of x squared. C is going to be the number that doesn't have any x at all. And B is going to be the number with just 1x. That's in front of just 1x. Okay. So I'm going to make some room here. Go ahead and delete some of this stuff. Excuse me. And now I'm just going to plug in the values. So the formula says minus b. And remember, minus b is the value that's in front of x. So it's going to be minus 0.5. Make that minus more clear. It's going to be minus 0.5. And I know the value is plus, but in the formula says minus. So we're going to make it negative. And then plus or minus b squared. That's when we use its original value, which is 0.5. 0.5 squared minus 4 times a. A is the number that's in front of x squared, which is 4. Times c, which is the number that doesn't have any x, which is negative 0.5. divided by 2a, which is 2 times 4, which is 8. Okay. And now we can just put this all in our calculator. So what we're going to do is, we're first going to square 0.5. So 0.5 times 0.5 equals 0.25. Then we're going to subtract that by 4 times 4 times negative 0.5. And this is going to give us, like, all of this is going to give us 8.25, right? So now the new expression is negative 0.5 plus or minus the square root of 8.25 divided by 8. So we're going to square root it. We're going to square root the 8.25. And then you're going to get approximately 2.87, right? So I'm going to change colors here. I'm going to change colors to this right here. And can I just scroll down? Oh, I can simply just scroll down. I'm going to scroll down. Okay. So this whole I'm new to this, so I didn't know I could just do that. Okay. So we know what the square root of this is, right? It's approximately 2.87. Plus, let's do plus first. You can do plus or minus, but I like to do plus first. Let's go ahead and do that. Plus negative 0.5, and then you're going to divide everything by 8. And 2.87 plus negative 0.5 is 2.37. So this will ultimately equal 2.37 divided by 8. And 2.37 divided by 8 is approximately 2.37 divided by 8 is approximately 0.30. Now, what is this number? This equation was used to solve for x. And what does x represent? X represents the change, right? Because we use that's a variable to represent the change. So this number right here is x. So now, all we have to do to find the equilibrium values is substitute x with 0.3. So I'm going to go ahead and erase some of this stuff because we don't need it anymore. I'm going to go ahead and erase it and use a different color. Okay. So we know that x equals 0.3, right? That's what we know. So we're going to substitute x. So for this N2O4, it's going to be 1 minus 0.3, and that's going to equal 0.7. So that is literally the equilibrium concentration for N2O4. Then we're going to do the same thing for 2NO2. We're going to put 0 plus 2 times 0.3, right? Because it's 0 plus 2x, and all we did was substitute the x for 0.3. And that's going to equal 0.6. So now we know we have everything. We just solved for everything. Change colors again. I like to make my screen look very colorful. So the problem gave us that Kc was equal to 0.5. And we used that and the quadratic formula to solve for x, the change, and the change was 0.3. And then we used the change to find the equilibrium concentrations for both the product and the reactant. So N2O4 is going to equal to 0.7. And 2NO2 is going to equal to 0.6. This is it. This is all the answers. Thank you guys. That is my first ever tutorial video. Leave a like and a comment. comment down what you want me to do a tutorial next of, and I will try to make one as soon as possible. Thank y'all, and y'all stay safe.